Hello! Ag Easy works with agricultural customers to help you save energy. The program, offered through the Public Purpose Programs or PPP charge on your utility bills, provides your business with energy audits, technical assistance, web-based energy monitoring, and more. Contact our team to learn how to take advantage of these benefits. In this video, you'll learn ways to save energy and money when heating a greenhouse. We will cover how heat is generated, delivered to the heated space, retained in the heated space, and ways to save energy in each of these areas. First, let's talk about how heat is generated when heating a greenhouse. Using electricity to heat a greenhouse can be very expensive, but occasionally, it can make sense in moderate climates if minimal heating is required. In these cases, heat pumps are the most efficient option. Typical heat pumps act like an air conditioner operating in reverse and heat the greenhouse while cooling the outside air. These are known as air source heat pumps and are generally more affordable than other types. If temperatures drop near or below freezing, an air source heat pump will not run efficiently. A more efficient option that generates more heat in cold weather is a ground source heat pump. A ground source heat pump pulls heat from the ground instead of the air and is more efficient because the ground temperature at a certain depth does not change much, allowing the heat pump to extract heat more easily. Instead of electricity, many greenhouses are heated with natural gas or propane using combustion heaters. These heaters require a constant supply of oxygen for combustion and use heat exchangers to capture the heat before toxic combustion gases are vented to the outside. More efficient combustion heaters do a better job of capturing heat by using more effective heat exchangers, but the greatest combustion efficiency is achieved by using condensing heaters. Condensing heaters capture so much heat from the combustion that the resulting combustion gases are cooled to the point that water vapor condenses out. The cooler combustion gases are easier to vent to the outside, but the condensate that forms contains caustic chemicals and must be disposed of carefully. Proper venting of the combustion heater can also improve efficiency. This involves making sure none of the heated air inside the greenhouse is lost to the outside. Avoid this by locating the combustion heater outside the greenhouse if possible. If not, there are two ways to make sure the heater is sealed off from the air inside the greenhouse. First, fresh air must be supplied for combustion. Avoid using heated air for this purpose by using a vent pipe to provide combustion air from the outside. Second, the toxic gases, which are the products of combustion, must be vented to the outside. Older style combustion heaters use passive ventilation, which relies on the hot combustion gases to naturally rise up and out of a chimney. This consumes ambient heated air around the base of the vent pipe. The solution here is to choose a power-vented heater, which uses a fan to push combustion gases up and out of the vent pipe without consuming ambient air. Opting for a heater with sealed combustion addresses both of these sources of inefficiency. A type of combustion heater that claims high efficiency through venting is called a direct vent heater. This type of heater claims high efficiency because it is either not vented to the outside at all or only for fresh combustion air, and therefore no heated air is lost to the outside. However, since it puts all of the toxic combustion gases into the heated space, the space must eventually be vented to the outside for safety. This eliminates any efficiency gained by not having the heater vented to the outside in the first place. Let's talk about delivering heat to the space. Some greenhouses use steam to deliver the heat, but steam requires a higher temperature than hot water or warm air and is the least efficient option. A simple way to deliver heat is to use forced air to blow heat into the space. However, because hot air rises, the airspace quickly becomes stratified, with hotter air near the roof and colder air near the floor. This is inefficient because most of the heat ends up where it is not needed. Heated air can be blown under plant benches for greater efficiency, but the hot air still rises quickly. A more efficient way to deliver heat is a hydronic heating system which uses hot water to deliver heat to the heated space and can apply heat more directly where it is needed, which, in a greenhouse, is where the plants are. This can take the form of hydronic heated floors if the plants are on the floor, or hot water pipes placed directly on or under the benches if the plants are on benches. Let's move on to the final concept and efficient greenhouse heating. Retaining heat in the greenhouse. Heat is lost to the outside through the outer materials of the greenhouse. Increasing the insulation value of those materials increases heating efficiency by retaining heat inside the building longer. Insulation values for greenhouse materials are typically given as U values, which are a measure of how easily heat travels through them. The lower the U value, the better the material is at retaining heat. The most common outer materials for greenhouses, in order of efficiency, include the following. Corrugated fiberglass or polycarbonate comes in rigid panels and offers minimal insulation value. Polyethylene film is a common material in the commercial and nursery industry because it is relatively inexpensive and simple to install. Double-layer polyethylene film significantly increases the insulation value while remaining relatively inexpensive, but it requires fans to maintain an insulating airspace between the layers of film. IR or infrared polyethylene film can be used by itself or as the bottom layer to increase insulation value. IR film is coated with chemicals that reflect radiated heat and shed condensation, both of which reduce heat transfer through the film. Glass is a traditional greenhouse material that can be expensive to install. Double-pane glass is relatively efficient since it has nearly doubled the insulation value of single-pane glass. Best insulation values can be achieved using twin-wall or triple-wall panels, which are rigid panels with built-in air spaces to boost the insulation value. Twin-wall and triple-wall panels can be made from polycarbonate, a rigid material. Twin-wall panels can also be made from high-density polyethylene, which is semi-rigid. Finally, depending on the greenhouse structure, an additional insulating layer can be added in the form of a thermal curtain. A thermal curtain is a horizontal layer of cloth-like material that is installed near the roof of the greenhouse and is typically open during the day to allow maximum light exposure, and then closed at night to retain heat. Here are the key takeaways for saving energy in greenhouse heating. If electricity is used, consider a ground source heat pump. For natural gas or propane, consider a condensing heater. Eliminate the loss of heated air to the outside by providing outside air for combustion and power venting combustion gases to the outside. Distribute the heat efficiently using underbench heating. Retain heat in the greenhouse using thermal curtains and better insulating material for the exterior of the greenhouse. For more information about potential incentives or to schedule a free energy audit with the Ag Easy team, contact us today or visit our website ag-easy.com.